Hi, welcome to Algebra 2 Common Core. In lesson number 6, we're going to take a look at how to graph our functions sine and cosine. Now, sine and cosine are both functions, so we're going to take a look at finding a table of values for these two functions. We're going to be referring to the quadrantal angles. Because we very often see these applications of sine and cosine graphs in physics and other higher level math classes, most of our trigonometric graphing is going to be done with our input, our angle, in terms of radians rather than degrees. So we're going to set up our table of values where we're using the quadrantal angles in radians. I think by now we're getting pretty good at converting back and forth between degrees and radians. So I've created the table where the radians are the x value. Let's go ahead and write down right above each of those radian angles what they would be in degrees. Let's start with the positives first of all, and then we'll go to the left with negatives. So I'm just going to put it right on top of this x row. So 0 radians would be the same exact thing as 0 degrees. Pi over 2 radians, we should all know that that's 90 degrees. Pi radians is 180 degrees. 3 pi over 2 radians would be 270 degrees. And 2 pi radians would be 360 degrees. Now, because we can also rotate in the negative direction, we're going to want to take a look at graphs where our x values are negative. So negative pi over 2 would be negative 90 degrees. Negative pi would be negative 180 degrees. Negative 3 pi over 2 would be negative 270 degrees. And negative 2 pi would be negative 360 degrees. We're going to use our unit circle and these quadrantal angles to fill out the table of values for cosine and sine. So if you need to, you can turn back in your packet to page, let's see, I guess that was page 6, where we had our unit circle. If it helps, you could also draw just a little sketch of your unit circle. And again, we're going to refer just to those quadrantal angles. So find the ordered pair at 0, at 90, at 180, 270, and 360. So take a minute to just find those ordered pairs, pause the video, and then come back when you've filled that in. So I'm referring to the coordinates at each of the quadrantal angles, and I know that the x-coordinate always stands for the cosine of the angle, and the y-coordinate always stands for the sine. So let's start with our cosine row in our table of values. Again, I'm going to start with 0 and then I'll go backwards in the table after I go forwards. So at 0 degrees, that means that I'm looking right over here and I see that the cosine, the x-coordinate, has an answer of 1. At 90 degrees, or at pi over 2, I see that here's my ordered pair, 0, 1. Looking at the x-coordinate, the cosine must be equal to 0. At pi, I'm looking at this ordered pair right here, and the x-coordinate is negative 1. So that tells me the value for cosine at pi. Continuing on around the circle at 270 degrees, I see that my x-coordinate is 0. And at 360 degrees, or 2 pi, I see that my x-coordinate is back to 1 again. Now we're going to go around the circle in the negative direction. So this time, negative 90 means I go this way, so I'm looking at the answer at 270. The x-coordinate is equal to 0. Go negative 180, so that means I'm following my arc this direction, and I'm using this angle right here. Ordered pair tells me that the x-coordinate is negative 1. Go back to negative 270, which would be equivalent to 90 degrees. So my x-coordinate is 0. And at negative 2 pi, I should be at negative 360, which is the same as 360. My x-coordinate is 1. Now, do you see that we have a pattern that keeps repeating here? We've got 1, 0, negative 1, 0, back to 1, 0, negative 1, 0, back to 1 again. So this curve is called a periodic function because it keeps repeating the same output values as I go through the x input values. Now let's take a look at our table of values for the sine of x. So for the sine of x, we are always going to be using the y-coordinate of the ordered pair. So at 0 degrees, the y-coordinate is 0. I'm going to fill this one in blue. At pi over 2, I see that I'm at 90 degrees, so the y-coordinate is equal to 1. At 180 degrees, the y-coordinate is 0. At 270 degrees, the y-coordinate is negative 1. And finish off my circle with 360 degrees, and my y-coordinate is 0. Now follow those angles around in the negative direction, and please complete the rest of the table. So at negative pi over 2, I should be getting an answer of negative 1. At negative pi, that should be 0. At negative 3 pi over 2, I'm back at 1 again. And at negative 2 pi, back at 0. I'm going to look at just one line at a time when I go ahead and do my graph. So you have this table in front of you. We're going to plot these points on the grid below. If you don't already have two different color pens, please pause the video and go find a pen or a pencil so that you've got two different colors. And in fact, on the next page, we're actually going to need 4 different colors if you've got them. So since I made my table of values for cosine using the black ink, I'm going to make the graph with black ink as well. Now first of all, notice that our x-axis is denoted with the radian angles. So I'm going to be following the radian inputs and looking for the outputs. Notice that my y-axis is not identified, so I'm going to go ahead and label. I'm going to have each box stand for 1. So this will be 1, 2, 3, and 4. Going down, negative 1, negative 2, negative 3, and negative 4. Now, of course, I see that this graph only has values of 0, 1, and negative 1. So using my input values, I'm going to plot the points that represent the outputs for cosine. So at 0, my output should be 1. So I'm going to get this point right here. And again, I'm starting with 0 and going to the right, and then I'll move to the left. At pi over 2, output is 0. At pi, the output is negative 1. At 3 pi over 2, back to 0. And at 2 pi, back to 1. Now be careful when you're connecting these. We should not make straight lines. These are actually going to be curves, and we'll see this in a few minutes on our graphing calculator as well. Now moving backwards, I see that I'm going to 0, negative 1, 0, and positive 1, and connect this with a nice smooth curve because this is called a periodic function. It's a wave. A cosine curve is a wave. So I'm going to label this one y is equal to cosine of x. Now let's go ahead and plot the outputs for the sine curve. So I'm going to switch over to blue pen and match my table of values. At 0, sine has an output of 0. At pi over 2, the output is 1. At pi, it's back to 0. At 3 pi over 2, it's negative 1. And at 2 pi, it's 0. So again, I can connect, or I can make the rest of the dots and then just connect them all. Going toward the negatives, I'm getting a negative 1 at negative pi over 2, a 0 at negative pi, a 1 at negative 3 pi over 2, and then back to 0. So I continue exactly the same pattern this time for sine. And let's label this graph y is equal to sine of x. Now what we're going to do is answer some questions about these two graphs. So question C says the domain and range of the sine and cosine functions are the same. State them below in interval notation. So for our domain, that of course is our x, or our input values. We've got our inputs as radians, but our inputs could have just as easily been in degrees. And I can measure degrees or radians as decimals, as fractions, positive values, negative values. So that tells me, because my graphs continue in both directions, that the domain for both of these should be negative infinity to infinity. Now the range, when I look at my y values or my output values, I notice both from the table of values and also from the graph that the range values go back and forth between -1 and +1. So I don't get anything outside of those range values. In Part D, we have an important definition. You might want to highlight this definition because it's something that we're always going to be talking about when we're talking about trigonometric graphs. After how much horizontal distance? So horizontal distance, of course, is referring to our x values. After how much horizontal distance will both sine and cosine repeat its basic pattern? So we can both look at the table and we can look at the graph and see that it takes 2 pi in order to repeat the same exact pattern for both sine and cosine. That is called the period of the trigonometric graph. Period just means what is the width of one of the patterns? What's the horizontal distance that one pattern covers? Because these graphs do have patterns that repeat, we said that this kind of graph is called a periodic function, a repeating function, repeating in a pattern. Now, if you don't already have your calculator, please pause the video and come back after you've gotten your calculator because we're going to talk about how to set up our graphing calculator to do these trig graphs. Okay, let's start on our calculator and let's make our y1 equal the cosine of x. So you can see that the first graph that I have marked here is y equals cosine of x. So label that on your graph. The next thing we're going to take a look at is how we're going to set our mode. We want our mode to be set in radian mode. So go into your calculator, press the mode key, and go down, and if it's already in degrees, let's change it over to radian mode. The next thing we're going to be looking at is going to be the window on our graph. I want to match the window to the graph that I have right here. So I want to make my x values start at -2 pi and go up to an x max of +2 pi. Go ahead and use the pi key on your calculator in order to enter these values in. So the x min should be -2 pi, the x max should be +2 pi. We're going to count by pi over 2, so make the step be pi over 2. Now you'll take a look at your y-axis here. For my y-axis, it's okay to go with a low value of -4 and a high value of 4, and go ahead and count by ones. Now we're just going to be doing the graph on our calculator. We're not going to be making a table of values. So for the first one, let's make the graph of y equals 3 cosine of x. So in y2, enter that function 3 cosine of x. Go ahead and press graph. And again, at any point, if you need to pause the video so that you can catch up on your calculator, please do so. So I noticed that with my y equals 3 cosine of x graph, this is a dilation of 3 in the vertical direction. So that means that every time my cosine graph had a height of 1, it's now going to have a height of 3. Every time it had a height of 0, 0 times 3 is still 0. Every time it had a height of -1, when I multiply by 3, I get -3. Back to 0 at 3 pi over 2, and then back to 3 at 2 pi. So all the places where my original cosine graph crossed the x-axis, I am still going to cross the x-axis because 0 dilated still gives me 0. -3 pi over 2 and -pi over 2 remain x-intercepts. Now go ahead and connect these points again in a nice smooth curve that looks like a wave. And I should clearly see that this graph is just a vertical dilation of 3. Label this one y equals 3 cosine of x. Now let's try the next one. So this time in y2, plug in y equals negative 4 cosine of x. So I'm going to switch colors here. I think I'll use a green one for this one. So if you've got a green pen, go for it. Now the negative 4 just tells me that not only am I dilating by 4, but I'm also reflecting across the x-axis. Now that's just the same as saying take the old output and multiply it by negative 4. So where my output used to be 1, my output is now going to be negative 4. Where my output was 0, it's still 0. Where the output was negative 1, now my output will be positive 4. Back to 0, and then back to negative 4. So I'm taking each of the points on the original cosine curve and multiplying their y by negative 4. Again, every time I multiply a 0 by negative 4, it's still going to be 0. So I end up with a graph that looks something like this. Try to make yours a little smoother than mine. My iPad screen is a little slippery sometimes. So I'm going to label that one y equals negative 4 cosine of x. So I see that this one is not only a dilation in the vertical direction of 4, it's also a reflection over the x-axis. Let's do the next one in a different color. I think I'm going to switch this time to blue. So we want 3/2 cosine of x. This should be a dilation of 3/2 in the vertical direction. 3/2 is just the same as 1 1/2. So I'm taking my original graph, and every place I had a 1, I'm now going to have 1 1/2. Every place I had a 0, I'm going to be back at 0. Every place I had a negative 1, I'll be at negative 3/2, and continuing on along the curve. So connect. And you're going to want to label your blue graph y equals 3/2 cosine x. Let's finish the last one, y equals negative 2 cosine of x. So this again is going to be not only a dilation but also a reflection. So I'm going to have a height of negative 2, then 0, then 2, then 0, then negative 2, 0, 2, 0, negative 2. Connecting the points. I've got a cosine graph that looks like that, so the red one is y equals negative 2 cosine x. Now in the box for the conclusion, let's just write down some of the things that we've found out by doing this graph. The capital A is going to stand for the amplitude of the graph. The amplitude just stands for the height. When I've got an amplitude bigger than 1, then that tells me that I have a vertical stretch. And again, a vertical stretch is just going to be a dilation. Now, could I also have a vertical compression? Yes, of course, if my A value is less than 1. What do we do to get our graph? We are going to multiply the output by A. And lastly, if we have a negative A, then that tells me that not only do I have a dilation, but I also have a reflection over the x-axis. The A, though, is still called the amplitude. So we always say the absolute value of A is the amplitude of my graph. Okay, you'll see example number 3 is done with the sine curve instead of the cosine curve. So I'd like you to take a look at what we did with example number 2, and using hopefully your different colored pens, I want you to plot the 4 graphs that we have right here. I'm going to stop the video at this point, and in class tomorrow I'll be checking your graphs in your note packet. So make sure that you have these 4 graphs completed for class tomorrow. Thanks very much for working with me on graphs tonight. Have a great night, and we'll see you next time.